Now let's start with the problems of circular measure. So as you can see, they have given this problem, and here in the diagram, ABC is an arc of the circle with center O, radius 5 centimeter, and angle AOC is 1.5 radian. Okay, so angle AOC is going to be 1.5 radian. AD and C are diameters. So the moment I see AD and C are diameters and O is the center, so obviously this is going to be 5, this is going to be 5. Okay, and this is 1.5 radian, this angle they have given. So obviously the other angle with respect to vertically opposite angle, that is also going to be 1.5 radian. And D is a straight line, so whatever they have given, just all the conditions. You have to find the perimeter and the area of the shaded region, so it will cover almost all the formula whichever we need for the circular measure. Now the thing is, if I want to find perimeter of this region, so we know that this is 5, this is 5, so we are done with this part, this part, this part, and this part, because all these are 5. So 5 plus 5 plus 5 plus 5, we'll get it. AC is going to be what? AC is nothing but a length of arc. So it's going to be length of arc, which is r theta, and at the end this is going to be 7.5 centimeter. You know, 1.5 into r, so you'll get 7.5 centimeter. Very easy. All we need is this ED. Now for ED, as I told you, you can use cosine rule, but we will avoid it as much as possible. So what we are going to do, we are just going to draw one line from this thing, perpendicular line, and this becomes a midpoint. So ED is going to be what? It's going to be 2 times EM. So ED is equals to 2 times EM. So as you can see here, radius is 5. This radius is nothing but 5, and this angle is going to be then 0.75. This. So as you can see, sine 0.75 is EM upon EO. EM upon EO. So definitely EM is going to be what? EM is going to be EO times sine 0.75, and this is nothing but the radius, so it's going to be 5 times 0.75, right? This is nothing but 10 times sine 0.75. Obviously you can use calculator. 10 times sine 0. Oh, 1 sec. So with calculator you will get 6.816. So perimeter is going to be what? Just add this length of arc 7.5 plus this 6.816, and finally we're just going to add 5 plus 5 plus 5 plus 5, all this thing, which is going to be 20. Whatever the value, that's going to be the perimeter. If you talk about the area of the shaded region, so this is going to be area of sector. So as you can see, I have find area of sector as OABC, whatever, OABC area of sector. It's going to be what? It's going to be half of r square theta, half of r square theta. Radius we know, angle we know, we can find out area of sector. And area of triangle OED, if I talk about area of triangle OED, it's going to be what? So we are going to use half of r square sine theta, so half of r square sine 0 EOD, which is nothing but sine 0.75. Using calculator we'll just get the values, so whatever it is, equal to. So if you just use calculator, here the perimeter is 34.316, this area is 18.75 centimeter square, this is 8.52 centimeter square, and total area is going to be just added 8.52 with 18.75, and you will get 27.27 centimeter square as your total area. Simple. Now second question, the diagram shows a circle with center O and radius r centimeter. The minor arc AB is such that angle AOB is theta radians. The area of the minor sector, so they have given that the area of minor sector is 48 centimeter square. So we know the area. Show that theta is 96 by r square. Area of sector is half r square theta. Just gonna substitute 48, and theta is gonna be what? 96 by r square. Very simple thing. Given that the minor arc AB has length 12 centimeter. Okay, so the minor arc AB has length 12 centimeters, so you need to find the value of r and theta. So maybe it's just a combination of two variables and all. So length of arc is r theta. We are just going to substitute length of arc as 12. We know r theta. Now instead of theta, we are just going to substitute 96 by r square in this equation. R cancel, and at the end you will get r is equals to 96 by 12, which is nothing but 8 centimeter. We'll substitute and we'll get this thing. Using your values of r and theta, find the area of the shaded region. As I said here, since we know r is equals to now 8 centimeter, yeah, r is equals to 8 centimeter, and theta is how much? Theta is 3 by 2. Is it? Yeah, theta is 3 by 2, which is 1.5. Okay, so we need to find the area of the shaded region. So as you can see, the area of the shaded region is going to be area of sector minus area of triangle. So area of sector, what is it? OAB. Yeah, area of sector OAB minus area of triangle OAB, which is nothing but half r square theta. Radius we know it's going to be 8, so 8 square into theta, which is 3 by 2. Also we can consider, yeah, 3 by 2. minus area of triangle, which is going to be half r square, so 8 square, into sine of 1.5 or 3 by 2, whatever. That's it. Finally, whatever the answer you will get. Obviously, you can use calculator and get the answer. So, of course, after using calculator, you will get 40.02 centimeter square. Centimeter, yeah, that's it. And this is another type of question they may ask you. So AOB is a sector of a circle with center O and radius 16 centimeter. AOB is 2 pi by 7 radian. The point C lies on OB such that OC of length 7.5 centimeters. So the moment I got this thing, I can find out that this is going to be 8.5 centimeter. They're asking you to find the perimeter of the shaded region. So for that, we just need length of arc here, AB. So length of arc is going to be 2 pi by 7 into 16, whatever the value we'll get. Then the thing is, we want here AC. BC though we know, which is nothing but 8.5 centimeter. We want this AC. Now here there is no other option. It's not going to be an isosceles triangle. So that's why here we'll have to use cosine rule. There is no other option. So that's why it's going to be AC square is equals to OA square plus OC square minus 2A OC cos of angle AOC. Of course, you know that. And finally, you'll just put the values and you will get the answer for this thing. Don't forget to take the square root of that AC. Okay, generally people forget it, that you get AC square is equal to something. You just put that answer directly. Don't forget to take the square root of it. Similarly, if I talk about this area of this shaded region, as you can see, this is the shaded region. It's going to be area of sector minus area of triangle. Same to same thing. Just here radius also, so it's going to be half 16 times. One second. Area of sector OAB is going to be what? It's going to be half into radius square. So radius is nothing but 16. So 16 square into sine of angle. Sorry, not sine. Directly 2 pi by 7. My bad. So it's going to be 2 pi by 7. Area of sector. Area of triangle half into this time. See, I'm taking 16 and 7.5. This 16 and this 7.5 into sine of angle between them, which is 2 pi by 7. After solving with respect to the calculator, you can get the answer directly. And there is one more question which I have taken another. See, in circular method, they have a variety of questions, like, every question is different, but at the end of the day, the concepts are same. You have to use all the similar things all together. So as you can see in this question, there is this rectangle they have given. Okay, and obviously if I just connect it, then it becomes a rectangle AB, and we have to find the perimeter and area of the shaded region at the end of the day. So now here what they are asking, show that the angle AOB is of 2.08 radian. Now also they have given that the area of sector AOB is 150 centimeter square. So obviously we are going to use the same formula. 150 is equals to half r square theta, and as you can see, it's going to be half into 144. At the end of the day, you will just get theta is equals to 2.08 by shifting here and there. Now if I talk about area of rectangle, area of this shaded region ADCB, it's going to be what? It's going to be area of this rectangle ABCD minus area of this shaded region, which is like this. This is area of segment. Sorry, area of rectangle minus area of segment. Now area of rectangle is very easy. It's going to be what? It's going to be 8 into this length AB. Now again, coming back to the same thing, like obviously you can use cosine rule for finding the AB, but I would still prefer that just make a midpoint like this, M. So we'll consider triangle OMA, and now AB is going to be what? AB is going to be what? So it's going to be, this is 12, and this angle we know, which is how much? 2.08. So this is going to be 1.04. Just make sure that you take half of it. And then AB is going to be what? AB is going to be 2 times AM, which is nothing but 2 times AM is nothing but, this is opposite side. So 12 sine 1.04. 12 into sine 1.04. We'll just use calculator for this thing, and we'll get 20.69, or we'll say 20.7. That's going to be the length of AB. Now once we know length of AB, it's going to be AB into 20.7. And now for area of segment, we know the formula, which is area of sector minus area of triangle. So area of sector OAB, which you already know by the way, minus area of triangle OAB. So just a second. So this is nothing but 165.6 we'll get, sort of. I mean, I just use that calculator value, that's over 165.6 minus Area of sector OAB we already know, which is nothing but 150, minus area of triangle. Again we are going to use half into r square. Radius is nothing but 12 square, so 12 square into sine of angle between them, which is sine angle between AOB. Okay, so sine 2.08. We'll again use calculator and we will get the final value. Now if we talk about the perimeter of the shaded region, so perimeter of the shaded region is going to be what? It's going to be length of arc AB plus length of arc AB, that means this thing, length of arc AB, plus this BC and AD, which is 8 plus 8, and plus DC we already know DC and AB are same because it's just a rectangle, so it's going to be 20.7. It's just going to add it and we'll get the answer. Length of arc, of course, it's going to be 12 into theta, r theta, which is 12 into 2.08 plus 16 or 36.7, whatever the value, that's going to be the perimeter of the shaded region. That's all you have in circular measure.